Jumbo. Today's lesson will be on covalent compounds, but before we get to that, it's a good idea to practice some ionic compounds, dealing with naming and writing formulas. And I posted this sheet on the site so you can actually try these questions on your own and then check them against this video to see if things are making sense. But you cannot afford to mix up ionic rules with covalent rules. You have to know why they have different rules, and you have to remember the rules. So for naming to a formula, the name is just giving us barely enough information to get to the right formula. We've got to write the symbol and charge of the positive ion and the symbol and charge of the negative ion. And then we have to cross those charges and reduce if possible. Well, ammonium is a positive complex ion. Dichromate is a negative complex ion. We know it's a complex ion because it says 8. 8 and 8 at the end guarantees that it will be a complex ion. So we look up ammonium here, and we see it's NH4 1+, and we come cruising down here, and we see dichromate is Cr2O7 2-. So we are going to write that information down, like so. There's our ammonium, there's our dichromate. Now we see a 2 is going to come down here, this is a 1+, it's going to come down here. And we don't write 1s outside the brackets, so we're going to jump the gun a little bit and go straight to that answer. And you should understand that. If you'd written Cr2O7 and with a 1 outside, that's fine, but then you would have to get rid of it. So it looks like this to be a correct answer. Next one says lead IV, that means lead 4 thiosulfate. So lead is definitely on our periodic table of ions. And let's see if we can hit the right thing. So we have the elements there, we go to the back side, we go to the ions, and we look at spot 82, and we see it's going to be 2+ or 4+. Don't worry about things like plumbus or plumbic. Ionic is an old naming system. We care about the Roman numerals, and we can see this is a 4+. Now we go to our complex ions, and we look for thiosulfate, and we find it right here, S2O3 2-. So we're ready to do step 1 and step 2. Bam, bam, and there we are. Now we have a 4 here and a 2 here, so we say, hey, we can do a crisscross, so that's what we will do. And when we crisscross, this 2 comes down here, notice no charge. And this 4 comes down here, no charge. We don't write pluses and minuses in formulas, only ions. And charge is written up top, subscripts written down low. This is still not a correct answer. It's the right ratio, but we can reduce these numbers. You can never reduce numbers inside the brackets. But this number here, this 2 for the lead, and the 4 for the whole thiosulfate, 2 divided by 2 becomes 1. 4 divided by 2 becomes 2. And we end up with a proper formula. Now, if you really know what you're doing, you could look back here and say, oh, this is 4+. We've got 2- here. It's going to take 2 of these beasts to kill the charge of 4+. And you end up with the same thing. The crisscross method is more if it's not making sense. Follow the steps and you'll still get the right answer. Aluminum iodate. So now we're going to find aluminum. We find a spot 13. And we see it can only have one charge, Al3+. So it's not one of these interesting multivalent beasties. And then we look up iodate, another 8. So we know it's a complex ion. And somewhere along here, you're going to spot it before me. We're going to find iodate right here, IO3 1-. So we're going to write out our symbols and charges. We are going to crisscross, and we quickly get that answer. And notice I did not bother writing a 1 there. If I had, that would make it incorrect. So that's 3 examples of names to formulas. Follow steps. You shouldn't go wrong for Ionic. Now we want to go the other way. So we're going to go formulas to names. I looked this up, and it's pretty obvious what I'm doing. I see Ca, and I go, whoa, that has to be on the periodic table. And it is, and it's always +2, not multivalent. This is brackets, so I know it's got to be a complex ion. And I come rattling down here and I look for hydroxide and I see it's OH1 minus. So I go boom and boom. And I did not have to put the charge in the calcium because it can only be 2 plus in the ionic compound. And that's calcium hydroxide. That's stuff used in grade 8 in the lime water lab. Stuff that goes cloudy when you bubble carbon dioxide through it. Next one's a little trickier because instead of just having a clear-cut metal and a negative complex ion, we have 4 elements we got to see. Does it split after the N, the H4, or the H? Well, if you're paying attention, it splits after the H4. So we're going to have an NH4 and we're going to have an HS. Those are both complex ions. So let's go find them. NH4 is the only positive complex ion, so we're going to write down ammonium. And then we go looking for HS. Now HS has 2 choices. You can call it bisulfide or hydrogen sulfide. You don't call it both, you call it one or the other. I'm going to call it bisulfide because that means I don't have to write as many letters. And that's really what chemists would respect. So, there's the ammonium for the NH4. There's the bisulfide for the HS. And ammonium is always +1, so I don't have to put any charge down. Last example says SbPO4. Well, Sb is on the periodic table, and it's spot 51. And it says +3 or +5. And again, you're not going to worry about the ic and the us names. You're going to worry about the ones with Roman numerals. So we know we're dealing with antimony. And then we have our PO4. And here's our PO4, and that's phosphate. So it's having these tools. We don't memorize these charts. We have them around as a tool in our toolkit. So we have Sb, and we know that's antimony. And we have the PO4, but we're also going to work out the charge. So when we look at phosphate, we see it's 3 minus, and there's 1 phosphate. That means the antimony has to be 3 plus to kill that charge. So now we've calculated charge, we put all the information together, and we get our antimony 3. That 3 came down here. And we get our phosphate, and we're done. That covers a fair number of the different kind of questions we can give you about ionic. It should be review. It should be easy. If it isn't, go back to yesterday's videos before you start covalent, because covalent rules are different, and you have to know why, and you have to know when and how to all use ionic and covalent rules. Enjoy.